Suppose I have a sequence like this. Let's say the first term is 1, the next term is 2, the next term is 4, and the fourth term is 8, and so on. Now you can see each term is the double of the previous term, right? 4 is double of 2, 8 is double of 4, and 2 is double of 1, right? And then the next term you can say it's 16 and 32 and so on, right? If you observe this sequence and if you take the ratio of the consecutive terms, for example, if I take the ratio of 8 and 4, then it will be 2. If I take 32 and 16, then it is 2. So if you take any two consecutive terms and take the ratio of that, it is coming out to be a constant and it is common, right? And hence it is called as common ratio. It is called as common ratio, and such a sequence is called a geometric sequence. Okay, it is also called as geometric progression as well. Okay, now this common ratio here is positive. It is not necessary that it is greater than 1 or only positive. For example, I can have another sequence like this. Let's say 1 by 2, and then 1 by 4, then 1 by 8, then 1 by 16, and so on. You can see the each next term is half of the previous term. If I multiply half with a half, you will get 1 by 4. If I multiply 1 by 4 with half, it will be 1 by 8. So here the common ratio R is going to be 1 by 2. What is the formula for finding out the common ratio? You simply take the n plus 1th term and divide it by the nth term. This is going to be the formula for the common ratio, right? If you want to take nth term first, okay, then you can take nth term in the numerator and n minus 1th term in denominator. This is also a valid formula. Anything where, in which the previous term is in the denominator and the next term is in the numerator is a valid formula, right? Okay, so in this case, if you want to find out common ratio, what you do, 1 by 4 divided by 1 by 2, which will come out to be 1 by 2, right? Now, there are sequences in which the common ratio is negative. For example, I can have a sequence like this. Can you see this sequence, right? So if I take the consecutive terms here, let's say minus 27 and 9, and if I take the ratio, this is coming out to be the negative minus 3, right? If you take minus 3 and divide it by 1, it is minus 3. So common ratio here is negative. So common ratio can be positive as well as negative, right? Now, how will you write the nth term of this sequence? Let's say the first term is a0 and the common ratio for these sequences are, okay, now this will be a0 into r, this will be a0 into r square, this will be a0 into r cube. You note that I am multiplying each term by r to get the next term, right? Okay, so now this is the first term, this is second term, this is third term. So what about nth term? You can see the nth term will be a0 r to the power n minus 1. Why n minus 1? See, for the first term you had a0 r to the power 0. That means it is r to the power 1 minus 1. For the next term you had, that is the second term, you had r to the power 1, which is nothing but 2 minus 1. The third term is like this, 3 minus 1. So I can write the nth term as n minus 1. So the nth term of this sequence is a0 r to the power n minus 1, right? Okay. So this is how you give the nth term, right? Now, what if I want to find out the sequence of first, this summation of first n terms of this geometry sequences. So then that becomes a series, right? So the series is nothing but a summation of the terms contained in a sequence. So let's say if I have the summation of n terms, then this is called as geometric series, right? So this will be a0 plus a0r to the power 1 plus a0r square and so on until you get the n term, which is a0r to the power n minus 1. Now I want to find out what is this summation, right? So how will I do that? That is the question. So what you do, you multiply this whole equation by r on the both sides. So if you do that, you get r times Sn. and this will become r times a0. So I will write it as a0r plus a0r square. Each term gets multiplied with r, right? And then at the end you will get a0 r to the power n, right? Note that there will be one more term here, a0 r to the power n minus 1. Okay. Now the next thing that you do is subtract this from the previous equation. So if you do that, then you will get Sn minus r times Sn as the left hand side. And if you see the right hand side, you can see a0r and a0r will get cancelled out. a0r square and a0r square will get cancelled out, and so on. And a0r n minus 1, a0r to the power n minus 1 will also get cancelled. So at the end, you will remain only with these two terms, that is a0 r to the power n and a0. So if I do this, a0 minus a0 r to the power n. Right? Now I want to find out Sn. So you can take Sn common and you will get a0 minus a0 r to the power n. Right? Okay. So the Sn formula will become, if I take a0 common, then it is 1 minus r to the power n divided by 1 minus r. So this is the summation of geometric series for the first n terms, right? So this you should remember. This is the proof of that, right? Now let's do some questions based on this. Suppose one simple series you can take. If you want to check out if this formula is correct or not, you take a simple series like this. And let's say I want to find out the first four terms summation, right? So I want to find out S4 for this sequence, geometric sequence. How will I do that? First term is A0, right? Here the first term is 1. So I put it 1 here. 1 minus, the common ratio here is 2. So 2, and this is, and the first four terms I want, right? So this is 4. So divided by 1 minus 2, right? Because r is 2. So note that here it is negative, the denominator. So this is 1 minus 2 to the power 4 is 16 divided by minus 1. So this is coming out to be 60, right? So if you look here, it is 4 plus 2 is 6, 6 plus 1 is 7, and 7 plus 8 is 16. So that is correct. Indeed, our formula is correct, right? So similarly for r negative also you can do the same thing. R fraction also you will get the same thing. You can do the same thing basically. If r is negative, then the denominator will become positive. So that formula you can substitute, right? Now the next thing is, if can the geometric series converge or not, right? See, in this case, this sequence is increasing twofold, right? Each term is increasing twofold, and as it tends to infinity, obviously the infinite, it will lead to infinity, right? The terms here in this sequence will go to infinity. Then the things will get not so good for us to find out the summation. Here the series does not converge, right? This does not converge because each next term is increasing more and more, right? It will increase double that of the previous, and as n tends to infinity, this series will tend to infinity. The summation does not converge, right? But when does it converge? It will converge if the next term is lower than the previous term, right? If the next term is lower than the previous term, then the series will converge, right? Suppose I have a series like this: 1, 1 by 2, 1 by 4, 1 by 8, right? I'm multiplying by 1 by 2 and each n. As n tends to infinity, the sequence, the infinite term of the sequence, when n tends to infinity, will become 0. So there is a chance that this series will converge, right? So to find out the sum of the infinite geometric series, what you do, you take a limit, the limit as n tends to infinity. So let me rewrite the thing again. Sn is equal to a0 into 1 minus r to the power n divided by 1 minus r, right? As limit n tends to infinity, as limit n tends to infinity, this is why it is 8, it should be infinity, right? So this is like this. So limit as n tends to infinity, is the summation that you get. So now a0 will remain as it is, 1 minus r will remain as it is, and inside you have to take limit as n tends to infinity of r to the power n, right? These are the rules of the limits. I think you know this. Okay, if you do not know this, you can just revise these rules of limits, right? These are simple, right? Okay, it's not complicated. So here 1 minus limit as n tends to infinity r to the power n. Now there are two cases. There are two cases. If modulus of r is less than 1, then the thing is, as n tends to infinity, the limit of this will become 0. So limit n tends to infinity r to the power n in such a case will be tending to 0, right? If modulus of r is less than 1. If modulus of r is greater than 1, then the thing will get a little complicated, right? When r to the power n as n tends to infinity has to become infinity, right? So this limit will tend to infinity because r is greater than 1. As I said earlier here the r was greater than 1, so the sequences will tend to infinity as n tends to infinity. But here this will not tend to infinity as you go further and further, right? So these are the two conditions. If the modulus of r is less than 1, then the series will converge. So then the series will converge and you can find out the sum of that. And if this happens, then the series will diverge and you cannot find the sum of this, right? Because the sum will also diverge. So as if I take modulus of r to be less than 1, then the series is converging and this limit will become 0, and as a result you will get this nice formula a0 upon 1 minus r. This is the summation of infinite terms of a geometric series, right? So here a0, this is a0r, this is a0r square, and so on. Okay, now if r is less than 1, if the modulus of r is less than 1, then you can directly form this summation. So in this case is I am going to find out the summation of this whole series. So 1, 1 by 2, 1 by 4, and 1 by 8, and 1 by 16. So 1, 1 by 2, 1 by 4, 1 by 8, 1 by 16, right? And so on. So here your r is 1 by 2. So what you get as a summation? So summation will be a0 upon 1 minus r, that is 1 minus 1 by 2, that is going to be 1 upon 1 by 2, that is going to be 2. The summation as n tends to infinity is 2 here, right? Okay, now what if you have a series like this, 1 minus 1 by 3, 1 by 9, minus 1 by 27. So here the common ratio you can see is minus 1 by 3. Now in this case, the summation will be 1 upon 1 minus of r, but r is negative in itself. So this will become 1 upon 1 plus 1 by 3, which is 1 upon 4 by 3, which is p by 4, right? This is the summation. Okay, so this sums up the geometric series and sequences. Thank you.